Hello, today I will show you Slop. So that's an IDE that I made with rock builds for CBABasic, which is a language I made up. So to generate this thing, what I did is start with a reference, which is CBABasic 4.5, and that's why it looks like for CBABasic 4.5. It's a fake console application using SDL3 as a backend, and yeah, that's the story. As a seed, and the seed is what I started with. I used 3-seater, and then I started encoding my language using the 3-seater API, and then I generated just to see. And from there, I said to the AI, okay, now I have this 3-seater with this JavaScript, and I want you to build the IDE around. Then it started building some stuff, and then I just did incremental changes, and I asked him to add more language features, etc. So in the end, I wrote little code, just did the base architecture, and then said, okay, from that, do the rest. So we can fairly say that it's Slop, but good Slop, and we'll see why. You can see we have a nice menu, and you can see the theme is not like QB45, but if I click here, now we are in QB 4.5. Let's load an example, and I will load a big example. It's the Metroidvania, and I will bump the fonts so you can see the details. So basically, it's a game where you shoot enemies and you go from room to room. So we need sprite and we need inputs, and that's why I have this controller on my desk. And you see that we have keywords dedicated to create palettes. And if I right click in the palette, you can see that I have, yeah, I will remove the thing, and we don't need the output for now. So that's the palette name, and it's explained quickly. Then you have the details, how it works, and that you have only 0 to 15 values. So it's a 16 color palette, and how to write colors. And yeah, that's it. That's palette. You have also patterns. Patterns, they are the images, they are your sprites, and each number is an entry in a palette. That's the ID. And you see, you can declare the size, and you can see if you take this one, that it's quite visual. The dot simply means that it's a transparent color. So yeah, a see-through color. So transparency between quotes, it's embedded in the format. Very easy format to understand too. These weird stuff, they are the name of the pattern, because you can do a reference to a pattern when you create a sprite. Okay, then I will look for sprites. So we have this lookup, and yeah, the first one is good, and you see that now I have a search result here, and I can click on search result, and it would jump on, and you can also do F3 just to move. So you see that we have a pattern. That is why it's look okay, because I want because it starts with sprite. Okay, but I wanted the sprite keyword. So there you have sprite, and you see that the sprite has a name, and then it has a pattern, and then it has a palette. And if I right click to have information, you see sprite name, pattern name, palette name. But like you see in the example, you can go further and say that you want some collisions. That's too far into. So if I look up maybe circle then. Okay, maybe I'm not using the I because that was generated by I. It's not using this syntax, but there it's defining the collision shape for the sprite by using collision shape. It's another way to do it. You have also this word floor map and style map. They are a trick to. I will just clear search results. Alright, yeah, no, I will. So I have also this floor map and style map. They are when you collide with a tile, you need to know where to set the height of your. So if you are in a slope, you need the contact point. And you can do a computation. You can know, okay, it's 45, so x equal y, and so if x is 3, then height is 3, which is the dumb case, but that way you can have any slope you want, and you just change the multiplier. But you can also just say, okay, this is this height, this is, and you do for each this. You give the y value for each x in an array, and that way there is no computation because it's just a lookup table. The nice thing with doing floor and cell is that it's very fast. It will take a bit memory, but it's very fast, and you can edit them visually. And everything I showed, you can in fact go into view, sprite and palettes, and you have an editor. So now you can just draw over. So to demonstrate, it's best to go through. See, I'm using the keyboard, and yeah, okay, this is working in this example, so I don't have to set up. I'm using the keyboard and I'm jumping around. I'm shooting and shooting the enemy. You see, all of these things work. And I can yeah, just duck. So yeah, that's the game. And let's say I want to change some stuff. So here I don't like the design of the floor. So I can go into sprite and palette, and this is the floor, rocks, and it is the rock pile. And I could, for example, just fill it with whatever color. So now they are plain. I will exit, I will run. And now, okay, I missed a pixel, but you got the idea. I see that it's done. I want to fill in the hole, then I would go into the tile map and the scroll wheel to zoom, and you see the tile map, and you see everything. It's already using the new palette. I will just draw over, voila, escape, start, and now the hole is filled. So yeah, that's the idea of it. And if I watch this thing, so you see it says tile map Norfair Caves, and yeah, it looks like where we started. So I can go here, and I will make sure that I'm in overwrite mode, because I will overwrite things. And yeah, these things you would do in CBABasic with data statement, and then you would do read. But there you can just say tile map and do your stuff. So I'm in overwrite mode, and I will hold the Alt on the keyboard. Yeah, okay, but I should put the cursor there first. I will do Alt, and then I would dig a hole again, so Alt, and then I highlight, and then I will hit the dot, and you see that it didn't replace the spaces, it just did replace the characters. It did that because it knows that it's in a tile map. If I was in a random text, like here, and I will make it looks rectangular, and if I do the same stuff, I hold Alt, and I do this, and I would say 1, for example. You see, okay, yeah, but that's a bad example because the grid looks like, yeah, but I have to change to so let's say I have something that looks like a grid. So you see now I have spaces, and I would do select, voila, and I would put a 2. Okay, I forgot to change the mode, and I would write a 2. It did overwrite the spaces because you are not in a tile map, so you probably want to replace everything and not just what is not space. But here, once you are there, it knows it's about space. Also, you see the cursor is in the middle of the tile map, and if I right click, it shows correctly the help for the tile map, because yeah, showing help for whatever would be there is not useful because it's your own data, so it will go to the right place. And so you saw the visual editors. Let's take something much simpler. That's Pong. Pong is very simple. So basically, you have this Pong game, and I can move the 2 paddles using 2 parts of the keyboard, and that's it. And for now, yeah, okay, it kept the previous bending, and you see that the left pad is bound to these triggers, and if I move other stuff, only the right pad is moving, but that's and this is not moving the left pad. So let's see how we can change that. And for that, you see here we have actions declared, and it says action. I could type something, I could just use the keyboard, but I'm lazy, so I can go to view bindings, and it will list the action, and player 1 up, I click, and I just do this, and player, yeah, but it's not player down, I do this, player up, I do this, and done. And now if I run it, I can use the stick. So very easy. It didn't change the source code. That's important to note. It's a binding that happens on in the IDE. So they are the developer binding, and then there are my bindings. And if I'm not happy, let's say I said A and B, and I would just done. So now I can use A and B to move the pad, and I'm not happy, and I want to reset to developer set bindings. Yeah, there is a nice button, poof, and that's what was in the code. And when you add an action as a developer, you don't have to know everything. You can just type your action on, then I will choose a key, I space, and you see that it did pop up the keyboard because yeah, you have to type something anyway, so why not pick it? But it's not yet available for it is, okay, sorry, I thought I didn't put it. So there it's for the controller, and same stuff, you can click, or you can just do the quitting and do stuff on the controller. and you see it did what the correct constant for you. And if I go to bindings, it's live, so the foo there is just set. These are things we just typed and they appear in the action. So this list is dynamic and it comes from the source code. And let's see now some interesting features by doing a run of the gallery first. So this is about patterns and palettes, and you see up and down simply change the palette. Space change the pattern. So that means you can have more varied enemies if your design is well done. And it's a form of compression, because if you were using PNGs, either you would have a shader to recolor them, or maybe something that would read the raw pixel. Once it's in a screen, you can read the pixel and change them. Yeah, there you don't have to do these things. It's a feature of the language. There is a support of matrix and of matrix expansion. So you can see that J is just 1, 2, 3, 4, and that's how you would code it. And R is equal to J, and then the number are around a J. And the language knows that it means it needs to expand J in place. And that's what the visual representation represents. And then you have state machine. And state machine are language constructs. So they are concepts that are embedded in the language. So here we have a door, and we can type the letters that are displayed at the bottom. How to open, and if it's open, I can't lock it because it's open. That makes sense. So I will close it, and then I will lock it. Now it's locked, and if I do open, it can't open because it's locked, and it can't close it because it's locked. So I have to unlock, and then I can't unlock because it's already unlocked, but I can open it. So that's handled through a state machine. There are multiple collections, so the data structure. You have the list and the set and the grid. And the list is like a linear array, like where you can add stuff and remove, more like a linked list. The grid is a flat array that is mapped to your dimensions, and so they are continuous in memory, and they are very fast, and yeah, they are nice. And the set, they allow only for unique elements, and not shown are the queue that are there. That can be FIFO or LIFO. So that's queue and stack, basically. And that makes implementation of anything much more easier. You don't have to re-implement them. CBABasic 4.5 didn't add those, so you would do ring buffer with an array to simulate queues and stack. It works very well because when you want efficiency and then memory predictability, it's often you would just say, okay, I make a huge array that would contain as many items I would need, and then yeah, I know that the space is there and I can use it, and it would be fast. So yeah, because the CPU would fetch the big chunk of it, and if your stack stays small, then the CPU would never hit memory again. It would just work locally unless it did load something else. So that's fantastic. But yeah, it's not the topic, but that's to illustrate why these things are useful. Yeah, the vector thing is built-in because in games you often use them. So I made them also a top-level construct. I skipped the last screen. Yeah, that was about the drawing and the fact that you can rotate them. This drawing is unhappy. So yeah, let's see how it works. This thing to quickly see the power of the language. I will just hide the help. So I said there is a state machine built in the language, and you can see that I didn't lie. Also, the screen it was 24 bits, and so that's why you don't have to specify it, and you don't have to specify the number of pages because it's double buffered by default. And you have to call flip to swap buffer after you have done your drawings. That's a decision I made to make it very, very simple. And that's a fake resolution. What it does is actually use your current resolution and then mimic the resolution. So if you say 200 by 200, it would make huge, 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 huge pixels using your current resolution. So it's just a view. And yeah, you can see how you can declare state transition. You can link transition to events, and they are the name. And then you can just use the state machine. Okay, it's not right after that, but we will see anyway. You have support of enum, and that's the matrix embedding. And you see 1, 2, 3, 4, and then you have the J 1, 2, 3, 4 that would sit here. 1, 2, 3, 4. It's not done at source level, it's done at runtime. Here I just decided to add spacing to make it more visual. That way you can see how it would expand, but it's not required. Okay. And there it's a proof that it works because J and RVs, they are the visualization that are grids. And you see that it pulls the colors from J and from R. So if J was not expanded into R, then the visualization would be wrong, and it was correct. So that means it worked. Yeah, you have the list set and queue, and you see that there are types, which would allow for further optimization. Right now, it's not totally optimized because it's just toy stuff, but it could be optimized because we know what we store, so we can do a better implementation. Like I said, maybe make a big array or something like that. The grid is, like I said, is backed by an array. And the bag is a dictionary. I did an, yeah, it's a dictionary or a map. Yeah, which is also a useful feature, obviously. And why does it use bag? It's just an example. We don't care, but okay. As for vector, you can see I use the curly braces, and this is done because curly braces are not used for anything else. It's easy to type and it's easy to see. So if you see braces, yeah, it's a vector. There is nothing else that would use braces, so it is. And you can notice I do this as equal, which is a shorthand to this kind of stuff. Because yeah, it can be painful to have to type as blah blah blah. So yeah, as a countermeasure to that, the language can do inference if the type is clear. And in those cases, it's clear. So that's the idea. You see that there it's using the standard stuff. Action we saw. Then we have these blocks, and these blocks are asynchronous. That means they will still execute even if you are in a loop or in a function. And the modification they do to global variable are visible in any context. So that's something to be mindful of. And now we have something interesting. It's the on-action next pressed gallery emit next. So gallery was the state machine. Yeah, okay, that's not that's not helpful there. So I did right click, and because there is no help and this is a variable, it knows it has to show where it is declared, and you could click there. I will not do, but if you click there, it will show. It will move to the place it's declared. So it's like a Control B in other ID. Then you see that it emits the event next. So then the state machine would move to whatever event it is, do the stuff. Yeah. Yeah, then okay. That's just handling a machine. You see that there it does access the current state of the machine to know what to show, and yeah, that's easier than having a switch mixed in. But you can actually in the state machine also do stuff on enter and on exit of events, but it's not used there. Yeah, maybe we can see in the help. There you can see that it shows it does the sound stuff. Or does it? Oh no, it's the yeah, there it's play sounds, for example. And you can play a full score if you want. It's not yeah, it's not only for playing one letter, one note. Then that you remember it's the door thing. And there that's the a machine which contains behavior to do stuff. So that's the text you saw in the bottom. Yeah, it's using the on-enter state to print the text, and the locate is like in basic just to print us at a specific place. Yeah, so you see that it's quite powerful basically. You can also do some drawing, and here you see the origin. So we move the origin, and then we can choose colors for fields and do rectangle and stuff. Then some patterns, but we already saw how it works. The palettes things, just basic ifs and stuff, so that's interesting. I'm scanning to see while playing do. Yeah, so that's a main loop. Yeah, that's not more and so okay, we can also switch the theme. Just because why not? And let's see a game now. So if it's a Space Invader, and it plays like Space Invader, and all the sprites that you saw are built-in, are in the source code. The idea was no too much magic, so everything should be in the source code. And let's call this. It's simple code. It's not. Yeah, no, it will not have interesting stuff because it's too simple. Yeah, it's too simple. And there you see the flip. Another interesting stuff is the flip will update a DT variable that you can use for movement, and that should be in platformer, but I think it's broken for now. No, it's not. Okay. So you see a nice platformer, and you see it's smooth and all. Up. See, pro gamer here. And yeah, this point after the flag is I stuff, obviously. So you see it use the enums that are finite set of values. It also use threads, and threads allow composition, and you see the threads is used in the hero as position, and then the position will be used to access its platform as position, foo as position. So you don't need to repeat the XY, that's the ID. And you see now the XY is coming from the position because it has XY. Okay, blah blah blah. Is it just threads that are interesting in that one? Yeah, but that's already a good thing to see. So you saw that yeah, you have types and threads. Yeah, I don't use the is, I think, so the I didn't use is. Yeah, the cover. Yeah, the quart should use more arrays and stuff, so that's another thing. See, the board is a grid and vanish, etc. So because the grid is a specific data type that is just making it convenient to use continuous arrays. And I'm not sure if it's properly documented. No, because yeah, it's implementation detail. Yeah, and you can slice this stuff, but I didn't use the slicing. Neither asked AI to use it. So you see that can do nice stuff. What is an interesting? Yeah, the Tetris is using the bag. Yeah, so it has to use fill bag. So it will, you see that it use a method on bag and then add stuff and use a shuffle. So they are built in the language, and also they have a function that would return a copy. So I made it so that when it's use the past tense or something like that, then it's a copy, and that way you can decide if you want to do it in place or in a new object. That sucks because that's bad. Yeah, it's a list. It should have used a queue or something because I made it so that the queue should be like shuffled around also. Let's see, collection, the queue. No, okay, that's why. Okay, so I would have to add shuffle to the queue because yeah, it makes no sense. But when you have a bag, what you want to do, yeah, bag in Tetris, it's a bag. So they put the 7 polyomino, then they empty the bag, then create a new bag, shuffle, and then empty it, etc. That way you are guaranteed to have the same polyomino every 14 draw. Otherwise, you could have be not lucky and have the n many times, which would be unfair. So that's why they do it. So there I would need a shuffle for the queue, and that way you or the stack, whatever, you could just remove, and it would use optimized data structure. Because yeah, if you remove the first element of an array, it's bad. Luckily, it was a list, so that's still good because yeah, the list is a linked list, so it's cheap to remove the header, the tail. So anyway, but I would have preferred to be a stack or a queue. But there That's why. So the thing. So I can do a bit of shit when you don't control it fully, and but that's more or less the takeaway of this. But it did shit that was still good enough because it's just conceptual stuff. It's still performance. Yeah, you can see the method of types in and out. But yeah, I'm sure that's voila. There you see something specific to grids. So board is actually a grid, and when you have a grid, you can use special for. Instead of nesting two for, you can have one for that would loop on X and Y. So it will loop columns and then rows, which is not intuitive because you expect that if you have an array of an array, then the easiest is to iterate the rows, so the first array, and then the columns, so the second array. But here, because it's a big array, it's a big array, it's a continuous array. Yeah, you can you can say like the first slice is the first line, the second line slice is the second line, and that way we can do iterate columns and then line, because you would read line by line, even if they are consecutive. I'm not sure if I make sense, but that's the idea. So this loop is very performance, because what it really does, it goes next item in the array, so just move a pointer, and yeah, that's it. So, and that means for the CPU, it's happy, because the CPU, what it says, okay, I would load a megabyte, and you are probably not using more than that. So you will never blow the cache, so no cache miss, etc. And for the programmer who knows nothing, yeah, this loop is better than two loops. It's just easier, so they would reach for that, and suddenly their code would be performant, just because they are stupid and they don't know. So I like this, obviously. So that's why I wanted to show it. And I don't see that in many languages. And even if it's very useful. Yeah, the clear line is interesting, but okay. Yeah, that's it. The rest is just basic code. There is a binary mark, and what's nice into that is just to show that it doesn't suck too much. See, we have 1,000 of them, and now we reach 30 FPS. But okay, my PC is beefy. And if we go into turbo mode, you will see something interesting. You see that it stays relatively stable. Now we are at 90, 100, and then it just stops. And why it does that? It's because there is a limit on the number of loops. Output, you see that it says, yeah, okay, you broke the limit. So there, that's because this loop is never interrupted. So after a million iteration, it would say it's too much. And that's something I have to change, because it's a good feature. It allows looking out the PC. But I need maybe to say that if you call flip, it would reset the watchdog. And that way you could, because the flip would also give some breathing room to the PC. So if you call it fast enough, then you are idling, which is very good. So I want you to call flip a lot, because that makes breaks that allows the PC to do other stuff. So when you call that, I should say, yeah, okay, now watchdog just reset, and I didn't did it. So when you're using turbo mode, it's yeah. But okay, Let's start again turbo, and I will spam the spacebar, and you see that yeah, I can put quite some bunnies, and it's yeah, it just have a good FPS. And why is that? It's because when you run it normally, it's slow, and there is no need to have this watchdog, because that's the tree that is interpreted, and so the interpreter can listen for escape and just do the thing, because it's very slow. So, and that's also, it checks each time is escape pressed. When you put turbo mode, it's use a VM, and it just the VM is just opcode, and then the parameter for the opcodes followed by opcodes, with also a pointer and a jump statements. So the loop are not enrolled, but it's like an assembly. So they are assembled into this jump to label and jump to this line, and then it just starts to continue to execute from where it was. So if you change the pointer, then yeah, the PC has no knowledge to just okay, next line, and then next opcode or next address, and then it will just read whatever is there. Now it has to execute it, and then read the opcode, read the next stuff according to what the opcode said, and continue. So it's very fast because it's very dumb, and that's why, yeah, if I had to add the escape everywhere, I would slow it down. So the escape is not used, only the watchdog that would just see you jumped, okay, and then I add one, and then when it's jumped enough time, it says okay, something is not right. But yeah, so it's fast because I just changing a number and then writing byte and doing what the byte describes. So it's a big switch and wide, and that's it. There is no smartiness. Yeah, so that's it's really like the CPU does the dumbest thing, so it can do it very fast. And the bunny mark is slow compared to something like Godot or Unity or any real game engine, because yeah, the texture, they are not packed, and the draw call, they are not batched. So when you say draw, it draw, and the start and end drawing is not the batching stuff. It's there to force you to use them. You could start drawing and then do 2 drawings and then do a new block and do that, for example. That would be very bad. But they are there because when this will be even more optimized, then I can use that to know, okay, I need to batch whatever you send between start and drawing. So yeah, that's why that exists. Yeah, yeah, that's basically it. So you see that this language, the ID and interpreter and boost was done by AI, and all I did was give direction. Like, okay, it should be a VM, it's bytecode, and I want a watchdog and stuff like that. And then I did the rest. And yeah, the difficult part then in that kind of stuff is the design. It's not the code. And then it's testing and understanding. And then when you don't look and read the code to see, okay, yeah, now it's misuse. I don't want that's bad, and I want you to do it a specific way. And sometimes yeah, you have to type some code and then say, yeah, look, that's what I would do, and then is it good? Does it match your things? And then it would reply, yeah, it's good because this and that, and then you can try and see if it works. So that's another way to work, where you try to do a little code just to nudge in the right direction, and then have I grab external resource to say, okay, but you did that, but maybe this is better, and then you can say, yeah, okay, that looks indeed better, do benchmark. Okay, that's the okay. Then go for it. Or yeah, no, it's bad. And yeah, I read and save and okay. This looks good, but in your case, da da da, and then yeah. So it just augments you, and if you suck, yeah, these things, for example, yeah, you can't do it if you have no knowledge of programming or languages or whatsoever, because you would not know in which direction to know. You would not know what is wrong. You would not know why it's slow. You would not know why it's display funky. There is so many stuff you would not know that the AI would just bullshit you through, and yeah, it would just become worse and worse and worse until it just stop. So that's the thing. For the so yeah, the help, you have the usual high-level contents that are categorized, like you can see, and the index that would show all operators words or anything that has been indexed. And yeah, you can see I have named color because that makes stuff easier. And look, yeah. I also added some mathematical writing because I found it would be nice and funny. I'm not sure if it's properly there, but yeah, because it was, but I think it's not there then. Yeah, because that's true. Let's do that up, and then and normally C equal no S equal no. That's bad because yeah, that question mark should be the union operator. What? Oh, let's see. No, okay. So the this is it was working at some point. So that's another thing. There are the AI regression. So you have to have some tests, which I have, but visual tests are harder because you need to look at them. And there are also diff. Yeah, so that will and normally it should maybe the I mean yeah. No, okay. I have also the in operator which allow to test if ownership. And the idea was to use the mathematical symbols because yeah, that they are shorter, and if you know them once, you know them forever. I also use the for operation to as set symbols because they are linked to Boolean logic. So like times to do the ending because yeah, 0 times 1 is 0, for example. So it's an effective end. And plus for the o-ring because yeah, if you have 1 plus 0, it's 1. And 1 plus 1 is more than 1, so it's 1. So that works. And yeah, the backslash. So this one, because I know that people are sometimes confused this backslash for the except because it's mathematical notation. And you see that there are error reporting, and yeah, no, it's not in but you see that 3 parse error, so because now it sees that it's not valid basic, so that's also to help the programmer. And yeah, I think I did the tour of it. But, no. I always a new stuff. because I use a tree-sitter, I also ask the AI to use the query of tree-sitter for search. So you can do a text search, but you can also do semantic search. For example, assignments, and it uses an S3 expression. It's like Lisp, where the brackets identify a node. So I'm creating a node assignments. The left is, and then a subnode identifier, and then that's a tag, which is the name of the node into the AST, abstract syntax tree. So it's just pattern matching the tree, basically. So now I can do a find arrow match, and you see that I can navigate this pop-up, but that's not interesting. So I would click pane, and you see there I have a pane, and I can move the pane, and I can just click an entry, and it will move to locate the string, and there highlights. This is actually a bug because it should not be red. It doesn't show as an error, but it's shown as red, and that's bad. I'm not sure if I also demonstrated this, so I will do it. There, if I do an action, I can choose the existing action. So if I do quit, then I can choose the modifier. I did that because there is no point typing what you already know. So there are very modern features hidden in a very retro theme. That was the idea. And the truth of the why I did it retro is because I find it less cluttered than classic like modern IDE. It's easier to focus on your code, and because it's code only, having this mouse for me is more visible, it's more visual, and also when you need help, I don't like to have a second window somewhere else. I always like a CBABasic way where you just right click stuff, and then you see the documentation just right there. It's just you click and you can read stuff. So okay, how does a while loop work? And I prefer to see an example. Then here it is, how it looks like. And another thing's useful is copying. I know it sounds stupid, but you do this copy, and if I paste, you see that it did paste the example, but what you can see is that the line here are not copied. So it's smart enough to know what you are trying to do, and just just do it. So these are design decisions that I had to do, because I would say, okay, you want to copy the help, here is nice borders. So you have to correct that, obviously. But so the idea is you can work full screen uninterrupted, and then you can F5 escape, and I also the accelerator. So the accelerator is the letters you see there. If I do Alt F, for example, so I can use a keyboard only. If I do Alt F, it opens the file menu, and now if I do T, it loads the Tetris example. And everything is keyboard friendly, because that's the thing with console stuff, even if it's fake console stuff. And that's that's it. That's the thing. Just quickly look at the another thing's interesting. This menu, so from welcome to more, is dynamic. So whatever you have in the examples folder, and then you can have subfolders with CBAB file, it will create a structure in that menu, and that way you can, for example, have mini template or starter stuff. You could create a new entry menu starters and then put your templates for different kind of application or whatever. And you can also see that it's smart enough to choose the right accelerators. So they are not hard-coded. Just see some menu and then try the first letter, and if it doesn't work, it's second, next, etc. So there it's yeah, that's it. The more would be a tour of the language, but the idea was to show that Slop can be good, but for it to be good, you have to be good. There is no shortcut. Thank you for listening to my TED Talk, and I hope you enjoyed this tour of the IDE, and that it gives you more insight on the use of vibe coding. But yeah, it can do quite complex stuff. It's not easy stuff. Bye.